वो लगाओ स्क्रीन, उनको भी दिखना होगा स्क्रीन। आजा देख लो। So we will do the inauguration a little while. Meanwhile, let us start something, because all of you who have come. So how many of you know large language models? Because that is the background needed. LLM stands for large language models. नहीं पता है? हाथ ऊपर करो. What about you?
Professor, we are not able to hear you.
Am I audible? Online. To the online participants?
Yes, yes, Professor.
Yes.
Thank you for the confirmation.
Yes.
So चलो खोलो. Just setting the context. So meanwhile they are reading with the inauguration. So yes, on karo pura full screen. Okay, so I hope this particular backdrop is visible and I am audible.
Yes.
So this particular technology called RAG stands for Retrieval Augmented Generation. G stands for generation. So generation means that if you are interacting with the large language models, LLM, and LLM responds to the user query. LLM responds to the user query based on the query it responds. So there are two problems, 1 and 2. What happens if, let us say, the LLM is not trained with the latest information? So latest information is not, let us say, that is trained to LLM. The second problem is that the source is not relevant. If it is not relevant, For example, you are asking a question from IRCTC, but instead of asking IRCTC, you are asking make my trip, or maybe somewhere else. So the source is not relevant, and the second thing is the information is not up to date or obsolete. There are two problems. What then in that case, this response which LLM will give to the user query is not satisfying the problem statement, or let us say the job, whatever you are doing. And especially this is not useful for the industrial use case. So there comes a RAG. So RAG, what it will do, so whenever there is a query will go to the RAG, it will retrieve that particular information, it will augment this particular prompt, and then give it to the LLM, and LLM will give a contextualized response, and people are happy. For example, you are a company, you don't want your information to be made public in LLM, but still you want all that information to be used. So every company is now building their RAG, and then they are using LLM for solving the problem of this company. So RAG means that generation part will be augmented with this particular retrieval. So how the latest information is to be stored. So for example, if it is the latest document of any company, then mathematically you represent your document in the form of vector embedding, and that vector embedding you store in a database that is called a vector database. So you have to build that vector database. So vector database, whenever it is there, so whenever you pose a query, it will go and retrieve the context related to your company or very specific information, and then augment it and then give it to the LLM, and LLM will give you the contextualized representation. This is all about the thing. Now the thing is, in this course, what are you going to learn? You are going to learn how to build this retrieval augmented generation, means vector databases, how you are going to mathematically represent your latest information of your company, something like that. So all the technology will be given and explored here in this 2 days workshop. So 2 days is not a sufficient time, but the speaker in this particular workshop is Anupam Purwar. He is from Sprinkler company, and he has developed so many RAG model for different companies. So he will be now handling this part over here. So I hope you have understood the context, which is so important that if you understand in 2 days, you will be useful for any job in the company, and so on and so forth. So all the technology will be explored over here in 2 days workshop, and you have to listen to this particular workshop. In the workshop, you will be required to use your laptop, and rest of the things will be guided by Anupam Purwar. Now over to the inaugural ceremony, which the organizers have planned. Over to them.
Thank you so much, sir. A very warm and a bright morning to each one of you present here. I hope my voice is audible. Okay. On behalf of IIT Patna, I extend a very warm welcome to all the MTech and the MSc students participating in the campus immersion program. I would also like to take a moment to introduce you all to our special guests. We have honored to have with us our esteemed dignitaries, Professor Anupam Purwar sir, Professor Rajiv Mishra sir, and Dr. Rahul Mishra sir. We sincerely thank them for gracing us with their presence and constant guidance. As a token of gratitude and respect, we would like to felicitate our distinct guest with a bouquet. May I request all our dignitaries to please come forward and accept the bouquet. I request Jaimangal sir to please come upon the stage and present them with the bouquet. I request Rajiv Mishra sir to please come forward and accept the bouquet. I request all the audience to welcome them with a huge round of applause. Now I would like to request our respected Professor Anupam Purwar sir to please come forward and accept the bouquet. Now I would like to request our respected Rahul Mishra sir to please come forward and accept the bouquet. Now, moving on to the first session of today's program, we have an exciting workshop on retrieval augmented generation, popularly known as RAG. As artificial intelligence continues to transform the way we access and process information, RAG has emerged as a powerful framework that combines the strengths of information retrieval and generative AI. AI to produce more accurate, reliable, and context-aware response. So I request Sir to please carry on with the workshop. Thank you so much, everyone.
Okay, a very good morning to all. So those who are doing this offline and as well those who are present online for this workshop, and a few second back I just seen around 100 people are joining online. So this seems how the peoples are really enthusiastic towards this workshop. Okay, and we had just limited seat, but now we have expanded it, and the gathering says that
Sir, you are not audible, sir. Rahul, sir, you are not audible. Anyone?
Sir, you are on
Send to,
mute.
send to me also. We are not able to hear, sir.
You can't hear, please. Can you please unmute, Professor?
The slide is not visible.
okay, now I hope I am audible.
Yes, sir.
Okay. Okay. So again, a very good morning to all those who have joined online as well as offline. And this workshop really going to be very much fruitful for all.
Sir, again you are on mute. Sir, you are on mute.
We can't hear if anyone is speaking anything.
I guess now I'm audible, online participants. Okay. Okay. So
Yes, sir.
a very good morning to all and
Yes, you
welcome to
are.
this workshop. Now the glitch is resolved and we will be audible throughout the session. And so without wasting more time on the introduction, so I request our esteemed guest to start our session. We will start this session within a few minutes. Soon the laptop and other things are set up. So I just request everyone to be very much vigilant and be available with your laptop and other stuff so that you can get more out of this. Okay. If just listening the things will be good, but will not work unless you run the code on your laptop and gain out of it. Okay. So thank you all and welcome again to this program. Yeah.
I think ठीक है ना, पोजीशन सही है। ठीक है, स्टार्ट करो। हाँ, यहाँ से ये मिनिमम, ये मिनिमाइज। Okay. So am I audible at the back as well? Okay. So I think Professor Rajiv already gave like a context on what is retrieval augmented generation. So what I am going to do today is like I will start with a case study. Okay. And this is something I have been working with a team of around 20 people. And yeah, we just wrapped up some of the results only yesterday. So there are a lot of improvements possible in this. And probably some of the students among you, if you are interested, you can also join this effort. So means we all talk about using language models, and then we have seen that yeah, they are able to produce output which most of the time looks very nice, right? Whether you use Servam, okay, or you use some Bharat GPT or you use Gemini, all these models, their response looks very rounded. If you guys can move here, then it will be easier for me to sort of communicate, okay, because there are a lot of empty seats here. Okay. So then whether the language model during its training has the exposure to that data or not, it will generate some response which to us or most of us would look very elegant. Now, one of the way to sort of address that problem where it sort of gives responses which look nice, okay, but which may not be factually grounded. So for that, people generally use retrieval augmented generation or RAG in short. Okay, so I'm going to use RAG only. Uh, but what about the other thing? Uh, like, okay, it is looking at the context that is provided, but is it really using it to generate the response? So that is a second problem, right? So information, lack of information can be addressed by using RAG, where you expose the language model to the additional information or context. But what about if it is really adhering to that information? And is it really generating the response using that information? So that is where using building AI, verifiable AI systems become important. And while when it is in information which is sort of textual in nature, uh, language models are able to sort of consume that and generate responses. For example, if you will ask about something that happened this year, say last month, okay, this Iran and all this Middle East tension that is going on. Suppose if you'll ask, okay, did Israel really capture a fort in Lebanon? Language models may not have been trained on that data. So it may scrape from the web and give you a response. Okay. But what about if it is an enterprise specific AI agent and it can't look at information outside and it only has exposure to information which is inside, right? So how do you solve that problem? So you'll have to upload that document, okay, say the news article, and then it will be able to generate a response. Now, when it is textual information or qualitative information, I'm going to use the term textual information or qualitative information interchangeably. So, in case it is either qualitative information, these language models have been trained on a lot of text data, so they are able to consume and sort of generate responses. But what about if the information is quantitative in nature, right? There are numbers, okay, there are hard constraints which are there. So how are the language models going to respond, okay, and adhere to the requirements that I mentioned? So one example of that would be, suppose uh, you have to make a 2D layout, okay, just 2D drawing you have to make. Okay, you are given a piece of land and somebody asks you that create a outline, okay, of the house. Now, why do you need to create an outline of the house? Puri building pe we can make a house, right? That's what people did. The hotel in Delhi did. They captured the entire area. There was no offset. Okay, and when there a fire happened, okay, they were like people could not escape, right? So that's what we see mostly. But when you go by the building standards, okay, building code, you have to leave some offsets, right? So, like if you look at this drawing here, like if say this is how the plot is, which is on the white here. Okay, this is the layout of the plot, and there is a tree also here. And inside there is a periphery of the house that has been drawn. Okay, based on some building standard. Now, if you have to solve a problem like this using language models, even though you will ask it, okay, you will give it, okay, that you should leave this much offset from the back, this much offset from the left and right. How do you know is it really following that or not? Right? So you provided the context that this is how you should do it, but is it really going to follow that? How do you verify that? So that is why, in addition to providing context, what also becomes important is you also verify is it really consuming the context and following whatever is written in the context. Now, when the context is numerical or quantitative in nature, language models are prone, okay, to sort of fail and sort of make something, okay, which may look okay, but which may not comply with all the requirements. Okay. So if you'll make a drawing like this, it will become very easily clear, okay, इसने offset follow करे हैं या नहीं करे हैं. ठीक है. Here it has followed, okay. So how did we arrive here? By having a verifier agent as well, which verified and provided the feedback. So like I will stop with this example. Okay, so this example was just to sort of make all of you think, okay, that it's not just about providing context, it is also about sort of ensuring whether that context is being used. So that is like the main idea I want all of you to have. And now we'll get into some of the concepts, okay, related to RAG. Okay, but keep this thought in mind, okay, at the back of your mind. And think about while we are building these RAG pipeline, how do we have the element of verifiability in that? Okay, because there's very little or no work done in that area. Okay, so and that's something we can discuss offline. Now, let's go to some of the theory that I came prepared with. Okay, so this is how like the regular pipeline for retrieval augmented generation look like. So before I really explain this diagram, how many of you are aware of what is a language model? Can just raise your hands. It will give me an idea. What What about the rest of the people? Have you heard about what is a language model, or how does it work? Okay, so that gives me an idea that I should also cover a little bit about language models here. Let me see, what do I have? Give me a minute, I'll open that topic related to. No, the material that I'm using here is already online, so you can go and download it. Okay. So, uh, a language model, by its definition, is something is a uh, like a transformer based architecture, which is trained on lots of data. Okay, and when I say it is trained on lot of data, like it all started with training them with textual data. Okay, and the way this thing actually came up is, back in 2017, transformer architecture was proposed. Okay, and then people built a language model called BERT. Okay, which was one of the first encoder based language models. Both of these things were from Google. Okay, Google Brain. And what people really observed is, it can mimic some sort of human thinking and memory, these language models, and they can learn and generalize like humans. Okay, and like in terms of their memory and it all depends on how many parameters the model has and how much training data are you throwing at it. Okay, so initial language models were able to do all these things. Okay. Now, if you look at any one of these tasks, like whether it is sentiment classification or text completion, summarization, code writing, translation, earlier there were like separate model that you will create. Okay. Like if some of you are exposed to natural language processing, you would know that for each of these tasks, there will be a separate model that you will train. Sentiment के लिए you will probably train a binary or a multi-class classification model. Okay. For translation, you may use something like RNN. Okay. So for each of these, you will have to use some specific model. But when we talk about language models, they have the capacity to generalize, and you can think of solving all these problems using one model. Okay. And then GPT came, okay, in November 22, GPT 3.3.5 came, okay. And then people started using, and then people are like, okay, this is great, okay, like it can do a lot of work, which I would have to spend time doing it on my own. So, if you are interested in knowing more about the architecture behind language models, you can read this paper. Attention is all you need. Okay, it's a paper from Google Brain, and one of the two primary contributors are from India. Okay, so I'll skip attention mechanism and all that, but I will try to bring your attention to this thing, which is next token prediction, because this is something which is very fundamental to language models. So I want you to understand that, because I didn't see like many hands raised when I asked about your awareness of language models. Now if you look at this sentence, fill in the blank, and it has to predict, okay, like what would be the last word. Now if you have to complete this sentence, okay, and pick one of the option, how will you do that? So if I ask you that what is the right response, how will you approach it? I means all of these can be right, all of them can be wrong. How will you approach it? Any fill in the blank is, if it is given to you, how will you approach? Right. Exactly. Right. So based on the context of last sequence of words. So that's what language models also do. Okay, and that is where the attention mechanism comes into the picture, because attention mechanism is all about consuming that context in a parallel way and making sense of what is being discovered, okay, in and around that sentence, and then you can actually fill in the word. So and how do you make a model learn this thing? So that is where next sentence prediction or next token prediction comes into the picture, where what you will do is you will give the like why during the training you will give a lot of such fill in the blanks where you would know what is the right response, right word, but you will force the model to predict that. Okay, and when you force it, it will have to learn. Okay, sometimes it will predict the wrong word, and then you will show that no, this is the right word. So it is going to you are hoping that it is going to learn from that. Okay, and you do that by using a data set which may have trillions of such sentence. Okay, so and then uh, when people did this, they realized that well, language models learned it. Okay, they are able to complete sentences. They are able to predict the next sentence. They are able to predict the next word. In fact, they are able to predict even the word. Okay, like if say there is a fill in the blank in the middle, that also they are able to solve. So, in fact, fill in the blank in the middle. What do you think? Is it a more complex problem or is it a easier problem than this? Like here it is at the end of the sentence, but if it is in the middle of the sentence, do you think it is an easier problem than this, or it is sorry? In that sense, yeah. Means in that sense, it is easier because you have the context on the right as well. Okay, but then you need bidirectional attention. You need to look on both the sides. Okay, so in terms of really sort of implementing it, yeah, you would need to have bidirectional attention. But if you have the bidirectional attention available, then yeah, yes, as you said, it can become an easier problem to solve. So people trained these language models on next token prediction task. Okay, and sort of that became the holy grail. Okay, because if you think about solving any problem, even say if you are responding in an interview, okay, to an interviewer, what you are doing, yeah, the person completes the question and then you start talking, right? And as you are talking, what you are doing, you may be building on what you said. Okay, in the first sentence, whatever you said, you use that as a context to continue building, right? Means if you don't do that, okay, like say the kids, okay, they will talk in small sentences here and there, and they will forget what they spoke earlier, right? Like 3 or 4 year old kids. Then because they don't have that attention, okay, they don't have the context, okay, and they will say a few things and then they will forget about it and then they will change the topic. But the way humans works, they build on the previous context, right? That's how you will appear intelligent to anyone. So now if this is a thing that a language model can also learn, then it will start looking intelligent to you, right? Whether it is really making sense or not, factually correct or not, you don't know. But because it is based on the previous context, you will find it intelligent and engaging. So that's how all our experience around ChatGPT, Gemini, and all that is actually defined, right? That we find them to be intelligent. So people picked that and started building a lot of language models. And now we say that language models have thinking capabilities as well. Uh, it's just that they have wired the attention mechanism in better ways uh, with some feedback. And now people say that they can think as well. But at the core, it is just doing a next token prediction. Even if we say 1 plus 1 is equal to, now it may look like a mathematical problem to solve, but if it would have looked at lot of data, it would have somewhere seen that okay, 1 plus 1 is written as 2 in probably 1,000 places. It has memorized everything. In fact, even the maths Olympiad problems, they are able to solve because they are able to identify, mix and match some patterns, and they are able to solve. Okay, but if you give it like a very strange problem for which there has been no training data, similar or relevant, probably it will not be able to solve. Okay, so well, there are some problems which like that which still exist. So there is a benchmark called Laft Humanity exam, something like that, or Laft exam of humanity. So that benchmark is full of such problems, uh, and uh, it is hard to crack it. So I hope now the context around what is a language model is set. Okay, so now I'm going to switch to the topic related to RAG. Yeah. Okay, before I go there, there's one more important component which is uh, prompt. Okay, so like everybody understands about what is a prompt. Right? Prompt is an instruction that you give to the language model. So be whatever you type in the chat, it's a prompt, right? So there might be a prompt, and you will also have a question. For example, you will say that, okay, look at this information and give me a response. So that is your question, right? And when you say look at this information, uh, sorry, look at this information and answer my question is your prompt, and then there will be a question, and then you may provided the relevant information. For example, you want to ask something about, say, chapter 18 of Gita. Like chapter 18 of Gita is sort of, Bhagavad Gita is sort of considered, I think, like one of the most important chapters. So now, if you want that, okay, I want a summary of chapter 18 of Bhagavad Gita, then you'll have to give it that chapter 18, right? If say you are doing that with ChatGPT, right? You will upload Bhagavad Gita, probably chapter 18, utne pages you will upload, or you may upload the entire Bhagavad Gita, and then you'll say, okay, this is my question that summarize, and the context is from the book that you uploaded. So I think all of you would have at some point of time uploaded documents to these language models and seen the response. But what if you really cannot upload? Okay, if say there is no such option, uh, and like organizations do that on a purpose because they want you to, like when you are using their systems, when you are using their application, they don't want people to sort of take the server down with lots by uploading GBs of data. So that's where organizations have started building their own RAG applications where they store the information in something known as vector database. Now, database everybody knows. How many of you have heard or known about vector database? Okay, many more people. So, what is a vector? Like when I say vector database, what do you understand by vector? Sorry. Okay, but we are talking about putting in textual information as context into the language model and storing it in a vector database. So, sorry. Okay. So, okay, scalar and direction. Somebody says mathematical representation, right? So, your language model is consuming text, right? And this text, how would a ML model, which is only parameters, would make sense of it, right? So, we know that, okay, like what these compilers really understand is binary, some sort of 1010, right? So, what all these machines understand is as numbers. Now, your text is not a number. How are they going to handle that text? So that's a potent question, okay, and I think I will have to again switch to uh, giving you some more context. Uh, let's see if I have those slides here. I think I don't have. So I'll use the whiteboard here. Uh, but I can just use Excel draw here. So if we think about it, representing words in two-dimensional space. Here you have, say, the word queen, and here you have the word, say, woman. Similarly, here you have the word king, here you have the word man. Right. So now if I try to represent them, okay, as some clusters, what you would like is you would like this to be one cluster, this to be another cluster. Right. Similarly, all the male things, okay, you would like them to be lying here, and the female feminine words you want to be place them here. Right. So what I'm doing here is I'm representing these words as vectors in two-dimensional space. And what I have here on the axis is a gender. Okay, and here something say I have royalty. Okay. So queen and king, okay, like they are high on royalty, okay, and then you have this gender, okay. So you can think of these as two dimensions, right? And you would also like if you say that okay, like these are really vectors, then you should also be able to do this thing, right? Uh, Queen minus woman. Uh, Let me know if this is making some sense. Does this make sense? Because these are vectors, right? Okay, if this is not making sense, probably this will make sense, right? Now is this making some sense? So, well, this is just an example, okay? I'm not saying this is correct. Okay, there is nothing right or wrong about it. But imagine if you can really represent words as vectors and you can do arithmetic over them. So that is something which is fundamental to these language models, that whenever you're putting the text into them, you have to convert them into vectors. Okay. And that is why the concept of vector database becomes important, because what you're doing is you're converting all the text into vectors. And that text is now stored as vectors into something known as vector database. Right? So now on high level, I think you have some understanding of what is a vector database. So with that context, let's move on, okay, to the slide on RAG, okay. So you have query, you have prompt, okay, you have some documents, okay. And where are these relevant documents coming from? They are coming from the vector database, right? So they are all stored, like what we do is in step one, we take all the documents, break them into smaller pieces, then convert them into vectors, and then store them in something known as vector database. Okay, so you have all your documents in a vector database which is hosted over some server. When your query comes in, your question comes in, you convert that also to a vector, and then you can always compare two vectors, right? Now you have a place, okay, which is called vector store, where you have all the documents stored in the form of vectors, and then your query comes in, which is also a vector. Now what you can do is you can compare the vectors which are stored here. So there are say n vectors here, and then there's this vector. You can compare these two vectors and then find out which all vectors in this vector store are actually similar to the query. Right? Vector similarity we all can calculate, right? How can we measure similarity between two vectors? Anyone? Yeah, some sort of distance. Okay, it can also be cosine, like the angle between the two. Okay, it is also known as cosine similarity. Right. So I think I can make it here itself. So if you think about, say, there are two vectors. These are two vectors, v1 and v2. To measure if they are similar, what you can do is you can measure the angle between them, and to that you can measure if this theta is 0, then what does it mean? Both are same, right? And if they are parallel, then also they will be sort of same. Theta will be 0, right? Okay, so uh, uh, so what we do is we measure the cosine similarity. It will be a value between 0 and 1, right? 1 means similar or same, and anything closer to 1 is also tells that it is similar. So out of this, say we have a cutoff, okay, that we will only pick vectors who have a similarity of more than 0.9. This is our threshold. Again, based on that, you found say 10 vectors are actually relevant. Okay. Then you will pick those, the relevant or the similar ones. Okay, and then what you will do, you will put them, you'll feed them to the language model. Say we found 10 of them were similar. Then they end up coming here, and then you pass them to the language model, which is again hosted over a server. Okay. So now the language model has exposure to the query, which will is also in the form of a vector, then the prompt also, which will also be converted into a vector, and the chunks also, which are also vector. If you are thinking loosely of text, okay, now it has all been converted into vectors, and then it is fed to the language model. Okay, so I'll sort of stop here, okay, to sort of see if there are any questions, because this is the fundamental of it, and we are going to only build on this in all the directions. So if there are questions, like even some obvious questions, I am happy to answer. Yeah. Do we have a mic, if because she will not be audible?
Hello?
Yeah, yeah, go ahead.
Yes, okay. Hello? Audible now, sir?
Yeah, yeah, audible.
I just want to ask, like, any example how we store that document in that vector database?
So there are different type of vector databases. Okay.
Okay.
So we'll look into it. So one of the vector database is FIS. Okay. So then there are other databases like ChromaDB. So we can use any of these vector databases to store the vectors.
Is there any way or rule like it should be stored in this way or something like that?
Yeah, I am going to cover that.
Okay.
Okay, I am going to cover that. Yeah, look. So your question is, why are we using vectors? So like all these models, all these computers, what they can understand is numbers, right? So you'll have to convert them into some numerical representation. And one of the ways to do that is convert them into vectors. Okay. And now this vector could be in an n-dimensional vector. Okay. The examples that I showed were like two-dimensional vector, but it can be n-dimensional vector as well. Okay. Uh, uh, I have actually like better illustration of that, but that will deviate us from the topic. But like let's look at it. Okay. Just a minute. Let me find out a slide around that. Okay, so this is one example of words represented as vectors. Okay, and the way this thing works is like when I was talking about n dimensions. You can think of, let's simplify this and think of say 7 dimensions. Okay, so here we have like 7 dimensions, and all these words we are putting a number between -1 and 1 for all these attributes. So if cat is a living being, yeah, it is. So we are giving a positive score. Okay, house is non-living being, so we are giving a negative score. Similarly, like we can talk about other attributes, human, gender, royalty, whether it is verb, whether it is plural, something like that. Okay, and you will say, okay, cat is not a plural, so you're giving a negative score. Now here I have sort of specified these dimensions, right? But in reality, okay, when we do that, there can be many more dimensions, right? For every word, there can be many more dimensions. So what is that dimension is known as the size of the embedding. And they are like in few thousands. Okay, 2048 or 4096, something like that. So and for the sake of simplicity, like if we convert the 7-dimensional to a 2D, then this is how we would like it to appear. That words which are closer in meaning appear closer together. Okay, so these are all living beings. They are appearing closer and far away from houses. And these numbers that you are seeing here are to be learned. Okay, so that's a separate discussion. But think of this uh, as something that has already been learned. Okay, and when it is learned, okay, you are representing these words. When you represent these words as vectors, then these vectors appear closer to each other. Okay, in case they are vectors of words in similar meaning, right? So I hope I gave you some flavor of it. Some other question was there?
So what problem would we rise if we
Somebody is asking a
store?
question, so let's come let offline. So let him complete the question. Then I'll come to you. Yeah. This will further get converted into binary. Okay, means this is not binary, right? This will be further converted into binary. Means when you write Python code, do you write it in binary? So if you convert everything in binary, now imagine like how like then you have only two states, right? How will you cover all the flavors that different words have? How will you do that, right? Now if you use something between -1 and 1, then you have like infinite number of states which are possible, right? So it has to be represented in this way, otherwise everything will be like black or white, okay, in the world. How will the variety in the meaning of different words be covered, right? Uh, okay, there was an online question as well from somebody. 1 minute. Somebody was asking a question online. Yeah, go ahead. Yeah, so these embeddings, okay, like the newer embeddings that we use, word to vec is also an embedding only, but as you said, like it does not incorporate the contextual meaning. Yeah, these methods are better, okay, because they are able to come with contextual meaning. Again, like sort of that is a hyperparameter. It can be anything. Okay, but you don't want it to be very large, okay? Because if you will make it very large, say 1 million, then it will become very sparse. You will have a lot of zeros because against those dimensions there will not be anything to put. So you try to strike a balance, okay, between being very granular and like again not run into the problem of sparsity. Any parameter for this type of? This is just an example, okay? This is a made up example. Okay. This is not how it is actually. Okay. So
Can
that
I
is
go
why
ahead,
we are
sir?
using RAG, right? So we feed that as a context. Yeah, so one example I took, right? You can upload it to ChatGPT, a PDF, and then it will have the context. Other way is you break it into chunks, store it as vectors into the vector database, and then that entire pipeline, RAG pipeline, you run over it. So that's why I spoke about verifiability. Okay. And you're saying whether it is proper or not, it will do a similarity based search. If it is not really relevant, it will not pull anything from that. Right. So if say the similarity score is less than the particular threshold that you have defined, where were we? I showed that, right? So if my similarity score, when I do a similarity search, okay, if my cosine similarity is below a particular threshold, then I will say it is not relevant. Right. So in that way, you filter out things which are just noise. Right. So then it will not consume anything. Means now, if say you are talking about say cricket World Cup, okay, and you upload something about football, okay, there will not be any semblance, okay. Team names may not match at all. So then it will not be able to respond, right? Because there's nothing it could retrieve. Okay. So if we have answered all the questions from offline participant, online participant, now you can go for questions. We'll go over your questions and then we'll move forward.
Yes, sir, I have one question.
Yeah,
How
go
are
ahead.
how are vectors actually stored and processed internally?
So we'll cover that, okay, after this.
Okay, sir.
Sir, one question from me. Sir, if the vector database is too big, so won't this matching, the prompt matching with the each of the vectors in the vector database take a lot of time to retrieve the information?
Yeah, so we'll cover that. Okay, so there are algorithms around that. Okay, so we'll look at how do we make. See, otherwise it becomes like an n log n problem. Okay, if it is really, if you're going to do like a search through the entire database. Okay, so it becomes an order of n problem. It will take a lot of time. So good that these questions are coming. So we'll look into how do we store the information, partition it for easy retrieval and search while using vector database. So we'll look into that. But architecture point of view, like, are there any questions? What is the context? Okay, how are we retrieving it? What is the embedding? What is a vector? If those things are clear, then we can move forward.
So, sir, if
Sir, one
query
quick
prompt
question.
and
Sir, is audible?
Yeah.
Yeah. This vector database, whatever is shown, sir, it is specific to problem statement. So how to find the which vector database, because there are maybe the commercial database available, the way we do it. So which is suited for the particular problem, how we can find out?
See, it all depends on the use case, and if you go dig a little bit deeper about which database stores the information in which way, and what is the nature of your data, I think you'll be able to find out, okay, what really matches with your requirements. Sometimes the priority is use something open source rather than use something which is like a commercial or a paid license. Then you will go for open source vector databases like FIS is there. And if say you're like, no, I don't want to sort of manage and maintain, then you can go for paid ones. Okay, like there are like lot of paid options like quadrant vector database is there.
so, sir,
So
if
any
query
questions related to vector database we can hold. Okay, like I'm going to get into that. Yeah.
Sir, I have one question. If query plus prompt plus retrieve documents all are vectors and fed into the LLM, then whether LLM also maintain its training data as vectors?
So vectors is a short way of saying that we are consuming some numbers, right? And when you are talking about training data, like, so language model or any ML model is not a data dump, right? So any model, any ML model is something which has parameters, and you can think of it as a very large polynomial equation of nth degree, and then it has got lot of coefficients. Okay, so what it stores is are the values of those coefficients, right? It does not really store information, otherwise it will become a database, right? So I think it's important to understand uh, fundamentally understand what is a ML model. So you can think of if you are aware of neural networks. So neural networks, what is there? They don't store any information, right? They store the values of their parameters. How many neurons, how many layers, what are the values of weights and biases. So those are the things that you store for the model. Similarly, for a language model also, you store some of those values which we call parameters. Okay, so there is no question of storing any information in a language model. Yeah.
Sir, how are OCRs different from RAG?
Okay, so can you explain me what do you mean by OCR? What is the full form?
So like optical character recognition. I
What does
used
it do?
one of the model like Mistral AI. So similarly, I am also simply uploading a document, say PDF, and it is helping me with the queries.
So fundamentally, what does OCR do?
So it is basically converting your PDF base into the text.
Right. And what does the Mistral do?
So, I mean, they are doing the same thing. My question is, if I am deploying an OCR model, so behind the scene, it is also leveraging the power of RAG itself. Is it right to say?
I don't know which language model you are using, so I will not comment on that. But your fundamental question was, what is the difference between OCR and RAG, right? So I think you understand RAG, okay, and you understand OCR also separately, right? OCR will only extract the text, right?
Okay.
And RAG is something like a pipeline. It's like a workflow, okay, where everything will happen, and RAG may not do OCR. Okay. And OCR will never do those things which RAG can do.
Got it. Got
Hello,
it.
sir. I am audible.
Yeah.
Hello. Sir, actually, I have one question.
Just a minute. Yeah, go ahead.
Yes, sir. So actually, sir, I have one question. So before storing any data into vector store database, we also used to chunk that data. My question is like how, yeah.
Just hold on. Okay, somebody's asking us. This we can discuss offline. Okay. I'm like questions are be around the topic only. Yeah, go ahead.
Yes, sir. So my question is, so before storing any data into vector stores, we also used to chunk that data. My question is like how to decide how much chunking we have to do. Suppose we have a paragraph database, so how do we chunk that data? And if we have a database in a JSON
Yeah,
format,
so that we'll cover. Yeah, that we'll cover. Okay, so I have not gone there. Okay, like how do we chunk it? Okay. Okay, so I think now the questions that I'm getting an idea that people are asking about things that are going to follow. So let's look at the following topics.
One question, sir, very relevant to this. What
That
you are
will be the
showing.
last question. Okay, on this.
Yes, sir.
Go ahead.
Sir, suppose I ask a question. What happened in the Iran-US war yesterday? So from some LLM model. So what is the query here and what is the prompt here? What is the difference between query and prompt here?
Okay, so where are you asking this question?
So yeah, from this flow diagram which you shown, so there are three inputs which are going: a query, prompt, and then the RAG. So it's the prompt is getting the two vectors are getting matched, and then the output is coming. The LLM is giving the output. So I want to know. So when I ask this type of question, what happened in the Iran-US war yesterday? So what will be my so it is going to scrap the internet, right? And based on that, because it's not been trained on such a latest data. So what would be my query here and what would be the prompt?
Okay, so see, I think this is something that pertains to some fundamental understanding of how ChatGPT or these applications work, right? Because I think your reference is how does ChatGPT do that? Am I right to assume that?
No, in the image which you are showing here at the moment. So here there
in the
are
image,
query plus prompt.
In the image I'd now like that I've shown, okay, like this is for something where I have a vector database. Your question is about scraping information from internet. So that is a very different question. So if you are asking about this diagram and there is the information say about the news in this vector database, then it will be able to fetch that information. Okay, your query and then whatever relevant documents are there. And if you are asking about, okay, what is the prompt here? The prompt may be as simple as that respond to the, okay, let me use an example. Okay, so look at this prompt. Okay, this is your entire prompt. These are variables, okay, like user1 and user2. And user2 memories, these are the context, okay, that you retrieve from the vector database. And this entire thing is your prompt. So the context is here, okay, and somewhere I think the query also goes. So this is actually for something different, okay. It is giving that, okay, these are the conversations. Yeah, this is the question of user2, right? So it is saying that this is the question, okay, and here some context is going about these two users, okay, and then this entire thing is prompt. So if we compare this with this diagram, so your query is something that is coming over here, okay, and your prompt is something which is this entire thing, okay, and whatever you relevant documents that you retrieve, they come over here, okay.
Okay, so understood.
Okay, that was without context, and this one is with context, okay. Okay, so this is the question, this is the context, and this is the information about the two users, and this entire thing is your prompt. Okay, so I hope now you understand it. And
So
if you are talking
queries,
about retrieving information from the web, then yeah, that information have to land here.
so query plus prompt is like prompt with context, right?
Yeah. See, what you can do is you can break this into multiple pieces, right? And then you can just say, okay, say this part is just my prompt. Okay. But in reality, you have to sort of fuse all them together, right? Then only it will make sense, okay, to the language model. So this one is a prompt without context. Okay, here we are just giving the user question and some information about the user and some instructions. Okay, and here we are also giving the context. Okay, that these are the relevant chunks that you were able to retrieve either from internet or either from the vector database. Okay, and then this is the instruction. Okay, yeah.
Okay.
See, chat GPT. So I would like make a suggestion that don't compare this diagram with chat GPT. Mm-hmm. Okay, so see, I think the way you are saying is, say if it is an open book exam, then along with your answer sheet, you're also putting the book inside it. Do you do that? So let me complete my example. So you will read something from a chapter, right? And then solve the problem using that information. You will not put the book also, attach the book along with your answer sheet. Similarly, here you don't put the vector database into the language model. You never do that. Whatever relevant information you got, only that goes to the language model. Okay, so yeah, if there are questions, just note it down. Okay, park it in your mind. Okay, we can discuss it offline as well. Okay, because I know 100% you may not get, probably 90%, 80%. Remaining things we can discuss offline because we have to maintain the flow as well. Okay, so I think some of you are asking about, okay, how do we determine, okay, what is the size of the chunk, okay, and so that is all these things, okay, like I think I will have to use the whiteboard now. Sir, I can draw on this, right? अच्छा. हाँ ठीक. Okay, thanks. So suppose you have paragraph. Okay, and say you have lots of lines of text over here. Now, so this is your document. The next thing that you do is you break that information in the form of chunks. I'm calling this C1, this I'm calling as C2. Okay. This I'm calling as C3. Okay, and you can have n chunks. Okay. Now, what could be the size of these chunks? Now again, that's a hyperparameter. Okay. It can be anything. Okay, 4,000, 8,000. Okay. So this is a hyperparameter, and which is up to you to select. Uh, and depending on what is the size of your chunk, say if it is 1024, okay, and this document has say 10240 tokens, then you are going to have 10 chunks, right? And now each of these chunks you will convert them into vectors, and then they will go to the vector database. Okay. Now, oh, they're saying whiteboard not open. Okay. Yeah. Now the next thing is what is the chunk overlap? Okay. So in terms of the chunks, okay. Now, suppose you have this sentence, sentence 1, and then there is sentence 2 which is starting here. Okay. And then you have sentence 3 which is starting here. I think this screen needs to be shared. So फिर इन लोग को दिखेगा probably. So now between these 3 sentences that we have, right now there is no overlap, right? There is no overlap. These are all independent sentences. Okay, and each of these sentences can be converted into a chunk. But then you have your chunk size, right? So suppose 1024 is not completing here, but it is completing here. Right. So then what happens is there is an overlap, right? Between these two sentences. Similarly, there can be an overlap between two chunks as well. So I have already filled this, so let me use this. So suppose your chunk 1 has got 1, 2, up to say 1024 tokens. Okay.
आगे दिक्कत इसकी नहीं है मेरे को कमेंट सुन रहे हैं फिर तुम वो तो देख रोज भी बता लेता है मेरे को बताते हैं कुछ सभी रवि क्या खा के आए हो हाँ
Can we mute this person?
खाना खा लो
And this is our second chunk. Okay. Now this second chunk is also 1024. Okay, and this second chunk has this starts from Tn minus 1 and then Tn. Okay. So between these two chunks, C1 and C2, two tokens are common. Right. So 2 tokens are common between these two. So now in terms of chunk overlap, what is the chunk overlap here? In terms of number of tokens? 2, right? So this can be 2, this can be 5, this can be 10. Okay. Generally, the recommended chunk overlap is not more than 10% of whatever the chunk size is. Okay. So if the chunk size is 1024 tokens, you won't have an overlap of more than 100 tokens. Okay. So if I say 100 are overlapping, then 100 are common between C1 and C2. Then 100 are common between C2 and C3. Now, other thing could be that overlap can be on both the sides. Right, for the first chunk, okay, the overlap can always be on the tail end. But for a chunk which is in the middle, the overlap can be on both the sides. So if I am saying 100 tokens is the overlap based on this 10% value, then there can be 50 tokens which will match with C1 and 50 tokens which will match with C3. Right. So that's what I mean by the chunk overlap. So I hope chunk size and chunk overlap is clear. And now if you are like, okay, what is an ideal chunk size or what is an ideal chunk overlap? I'll take I can direct you to this paper, okay. Uh, okay. So in this paper, actually, we have given some ideas, okay, around what is an optimal chunk size, what is an optimal chunk overlap. Okay, so if you're like, okay, I want to sort of engineer something and I want to make it sort of more optimal, then you can look at this paper. Like we have done a lot of things, like on different data sets for different models. We have evaluated the impact of chunk size and top K. Okay. And then we have showed, okay, like what is a good chunk size. Okay. And we have shown like if you look at this, some plots are also there to help you understand like what is an optimal chunk size. But generally, like 1024 is a good chunk size. Okay, generally. So you can look at this paper if you are sort of, so to some of the people who are asking like what is an optimal chunk size, how do you decide that, you can look at this paper. This is something which is like a more detailed study around this, and we did this for 2 open source models, Mistral and Llama. Okay, so along the same lines you can experiment for other models also and see what would be an optimal value.
Sir, I have one question.
Yeah.
Like how chunking size depends, like what it helps, like if we are making a rack chain, like how the chunk size helps in optimization, like, how it does. If we do, suppose if we do any chunk size, how it can be less optimal. Like, if we do a perfect chunk size,
Yeah,
how
that's
it
a
can
good
be
question.
optimal.
Okay, let me respond to that. So for that, one more thing becomes important to understand, which is the context window of the language model. So how many of you understand about the context window? Okay, some of you understand. I think if you had used ChatGPT in 2022, anybody remembers using ChatGPT in 22? क्या होता था उसमें? हाँ?
It has some limits. We
हाँ, it
cannot
has
send
some
more
limit.
than 1 minute of text.
Yeah, exactly. ठीक है. Now they have like million tokens as a context window and infinite also. So you don't really see that problem happening. But if you'll upload a very large document, say which exceeds the context window, then what will happen? It will not be able to give you a response. Which it may hallucinate or something like that. So if your chunk size exceeds the context window, okay, then that chunk itself will not fit in the context window. Right? So your chunk size should always be lower than your context window. I hope that is clear. But within the input that is going to the language model, there are other things also that are going in. Right? What is going? Query is going, then prompt is going, and so query and prompt are consuming some context, some percentage of the context window, say 10%. Then the remaining 90% is left for your retrieved documents. Right. So if your one chunk is going to exceed the size of this 90%, then it is not going to work, right? So one sort of upper limit is it should not cross the context window of the language model. Okay, suppose you have a chunk size in a way that it is say 80% of the context window. Okay, then what will happen? You will only be able to retrieve one chunk, right? You will only be able to fit one chunk into that. Right? You will not be able to fit more chunks than that. And what if your information is lying in some other chunks as well? But you can only retrieve one chunk. You can only fit one chunk. Relevance will be lost, right? Okay, because you can only fit one chunk into the context window of the language model. All the other relevant information will be gone, right? So, in order to really get a good quality response, what you would like is you should have a capacity to pack multiple things in the context window, right? So, for example, if you say go to exam, okay, where you have to write things, okay, you would like to carry a pen, a pencil, a rubber, a scale, everything, right? A sharpener as well, right? You won't really buy a pen, okay, which is that thick and that long that only that can fit into your compass box. Similarly, in the language models context window also, you would like to put chunks in a way so that you have all the variety of information available which is relevant to the query and based on which you can get a good quality response. Okay. Now, if you are somebody who is really like interested in getting to the depth of it, okay, I want to know what is the optimal chunk size, then yeah, of course you can write a paper like I did with some students, but go with this number. I think 1000 or 2000 tokens as the chunk size. You will be safe most of the times.
So basically, sir, it depends on the LLM token size, how much it can
Context window
take.
size, yeah, that is one guardrail, you can say. Yeah, go ahead.
Yes, got it, sir.
So what one of the attendees is saying is, suppose for a given query, you're getting 100 chunks which match more than 90% similarity, right? And for some other query, it is only giving say 5 chunks that match. So see, that is something you can't hard code, okay? Because the query can be anything, okay? So, but what you can always sort of be clear about is you always know what is the context window. So I will always use that as the upper limit. Okay, how many chunks match or do not match? Uh, that can still be handled. Okay, by putting some thresholds. Okay, like if say 100 chunks are matching, you will put another threshold. Okay, you will say, oh, I will only pick the top 10 out of it. So that's where this other hyperparameter that becomes is the number of documents or top K value. Okay, so you will say, okay, 90% is my threshold. 90% cosine similarity is my threshold. Other thing that I will look at, uh, say 100 documents or 100 chunks are matching that 90% threshold, but you will only pick the top 10 out of it. So that is your top K. Or you will pick, say top K is 5. Then you will only fit those 5. Now that top K is governed by the chunk size as well as the context window that the language model provides. Okay. So long story short, you need to have chunk size, chunk overlap, and top K. All these three things sort of fine tune that or like sort of do some grid search uh, while building the rack pipeline. Yeah.
Sir, I have one more question. So suppose when we go for fine tuning the LLM model, so do we can change these parameters of all?
No, fine tuning is a separate topic. Let's hold on. Fine tuning is a separate topic. So let's do one thing. So for online participants, I will let you know, okay, because some offline participants are also asking questions. So let's have some boundary. Okay, I'll just indicate, okay, when we can entertain online questions. Yeah, go ahead.
Let's say user asks give me the summary of Mahabharata or give me the summary of the whole Bhagavad Gita. We cannot give the whole Bhagavad Gita or Mahabharata to the Gemini because, as you said, there is a context window. Then how will this RAG pipeline will give the summary of the whole?
Yeah, it will fail. Simple. It will not work because you can't really fit everything inside it.
Okay, so like we are building a production system where this fails. Like, do we have any alternative or like fallback of this situation? Like even the user asks how many chapters are there in the Bhagavad Gita, how will it give the answer?
So well, so there are ways of doing that. Okay, so look at any book. Okay, always the book starts with an index table of content.
Yes, like
right.
We are building a RAG for like user can ask question in natural language,
So
not in
okay,
query.
so let me complete my thought. So what is the purpose of table of content?
We don't like ask user ki what is the purpose of this. We give the bot and कि
I'm
पूछो
trying
भाई जो
to
पूछना है.
point you to something more fundamental. Any book that you open,
Yeah.
any book in the world that is written, there will always be a table of content, and some good books would have glossary as well.
Yeah.
What is the purpose of that?
Just to go through indexing, yes, right.
Right. So that is information of information, right? That is meta information. Okay. So when we know, means like I think this is something people have been followed for hundreds of years. Even Mahabharata or Bhagavad Gita, whenever it was written, it was broken down into chapters. People were very intelligent at that time also. They knew okay, this search and retrieval is a challenge. So they broke it down into chapters even at that time. Okay, when we wrote those books. And they used to have verses and paragraphs. So why did they create that? Why they created that so that information retrieval is easy. Now coming to your question, how do you search and how do you summarize? The answer is same. Use the meta information. You know there is a limitation. Okay, the people who wrote Bhagavad Gita knew that human minds would have a cognitive limit. So they broke it down into paragraphs and verses. They did not create a monolith, right?
Okay.
So they solved that problem thousands of years ago. So you have to use the same intelligence now.
Okay, so
feed meta information.
So the question was more about the production we are building for legal RAG, where there is a judgment, and in a judgment we have citations. So let's say a user asks this versus it, explaining the case of this, then how will the RAG will see the citation and citation के बाद फिर दूसरा judgment,
I will
फिर दूसरा
suggest you
judgment का
one thing to
citation.
read, okay, because I have to cater to the entire audience here, and your question is very specific. So look at something known as page index. Read that and come with that, okay, tomorrow.
Okay, so
okay, that will help you.
Can you repeat the
page index?
Page index.
Page index.
Thanks.
Okay, there is I think ACL or ICML paper around that page index, and now that paper has become a company, okay, of a few $1 million. So look at that.
Okay, thanks.
The vector list, right? Yeah. Online participant, I'm going to come back to you. Okay, let me respond to the questions here.
Am I audible?
Yeah.
So you talked about the chunk overlap. I wanted to ask, in that chunk overlap, are the words random or is there a context to that also?
Words random, what do you mean? It is the order of the words will be the same as in the sentence, right?
So between the chunks, different chunks, there's overlap. So is that context sharing between the chunks also, or is there any significance of the overlap?
Yeah, there is significance. Okay, so good question. Okay, so this is so his question is, why do you have overlap? Okay, between two chunks. The reason is when you really break the document into chunks, it may so happen that you may end up breaking the sentence in the middle. That could happen, right? And we don't want that, okay? Because if you break the sentence in the middle, then the flow of information, the visibility of that information goes away. And you will be putting a threshold. You will say, okay, I will only pick say five most relevant chunks. Now, if that sentence is not complete, because you have cut the chunk, okay, somewhere in the middle, then that chunk will not have the full meaning. So to avoid that, what we do is we allow some spread on both the sides. so that even if you end up breaking a well meaningful sentence, at least you have some grace available on the either side. Even in terms of chunking and then storing, there are different techniques. Okay, so there is something known as semantic chunking. Okay, you can look at some of the chunking strategies. Okay,
Okay.
so they take care of all those things.
Okay. Thank you.
Okay, any more offline questions? No? Okay, so now we'll switch to online and then we'll proceed. Okay, yeah. So online participants, you have any questions? No, we can't make chunking dynamic. That's not advisable. Because every chunk you are going to map into a vector. Okay, and that vector size is sort of fixed. Okay, so if you compress a very large chunk into a small vector, then you'll lose a lot of information. So I would never recommend like having like different chunk size for the same vector database. So yeah, go ahead.
Does chunking size also increase the speed or decrease the speed of the retrieval?
Yeah, of course, it will change. Yeah. So we'll go into the retrieval part, okay, the vector database now. How do we store the information? How do we retrieve the information? Okay. So the last hyperparameter is chain type. Okay. So I'll not really go into much details of this. This is actually a topic related to information retrieval. Okay, so there's the entire IR domain which talks about this thing. I think MapReduce you might have heard, right? Hadoop, MapReduce. So this is something inspired from that. So I'll just explain the chain type, which is stuff. Okay, so in case of stuffing, you'll just put all the chunks. You'll not do any more refinement over it. Say if you retrieved say 5 chunks, which are within the top K, you'll just put them as it is. Okay, you are not doing any more transformation over it. But in case of other approaches, you do some more refinement. Okay, so you can use any of these and see like what is working for you, what is not working for you. Okay, in case your chunks are very large, then I would say go for MapReduce. Otherwise, stuff does the job. Okay, most of the times. Uh, uh, let's cover about some metrics also. So, okay, you have your rack pipeline. It's doing well. Acha, temperature. Okay. Uh, Sorry, I've skipped that because I was assuming that like temperature is something that you would come across while studying about language models. So anybody remembers like what is temperature in the context of language models? Randomness. Okay.
Find the strictness and the randomness.
Okay, let me draw something. That will be easier to understand. Okay, I am just giving you a flavor. Okay, don't just assume that this is mathematically to the point. So language models are predicting the next token. How are they predicting the next token? They're calculating the probability of that. Whichever has the highest probability, say out of all the words in the say Sanskrit or Hindi, it found that okay the probability of say the word Ram is actually the highest, so it will predict that word. Uh, but it won't be that only for the word Ram the probability is like close to 1. There will be other words also which will have non-zero probabilities, closer to 1 or close to 0.9. Right. So now what temperature does is it sort of puts some cutoff. Okay. So suppose this is your probability distribution. Okay. The area under the curve is 1. Okay. And you will put some sort of cutoff. Okay. That uh, if say the temperature is actually is close to 1, then this cutoff that you are putting will be very wide. Okay. What you will do is you will pick up all the words which are lying within this probability values. Okay. Let me use some other color. You'll pick everything which is in a broader interval. And if your temperature is actually low, say close to 0, then your interval will be very narrow. Now what will happen? You will only pick from the words which are lying in this smaller interval. Okay. So if your temperature is high, then you will end up picking words which have lower probability. Okay, along with words which have high probability. But if your temperature is uh, low, close to 0, then you will pick words only which have very high probability. Okay, so that is a term which is very specific to the language model. So I skipped it. But in some of the RAG pipelines also, when you are calling that language model, you can specify temperature as a setting. And now I think the language model providers, they are taking it out of fashion. Means now you cannot specify. They have hard coded some temperature. Even if you provide, it will override. Okay, so it was more relevant earlier, but now means there's not much you can do. Okay, but if you're using open source model, then yeah, still temperature as a setting will work. Okay, so let me come to the evaluation part. Okay, means just like when you read when you as a student study a course, finally you have an evaluation component, right? Similarly, for a rack pipeline also, you'd like to evaluate like how good it is. These are some of the metrics, okay, for RAG, and the ones which are very related to RAG are this recall oriented score. Okay, so what it does is it tries to match or compare whatever context was provided and whatever response was generated. It tries to find the overlap between that. Okay, so this is a very good metric for RAG. These metrics were actually used earlier for machine translation. So this is coming from classical NLP days, but this is something which is very relevant even now, okay, in the case of RAG. Then for question answering type of RAG agents, you can have this F1 score and accuracy. Okay, so accuracy will be like how many answers match with the ground truth. Okay, and F1 score will be like it's a cross between precision and recall. So you can calculate, you can use any of these three metrics to sort of put an evaluation around how good your RAG agent is. People have come up with more frameworks. Okay, so this holistic evaluation of language models, this is a framework from Stanford. So they are looking at lot many things. Okay, they are looking at accuracy, calibration, robustness, fairness. So looking at all these 11 metrics here. Okay, in order to make an evaluation. So up to you, like whether you want to just stick with these some standard metrics or you want to do the evaluation against all of these. So all depends on your use case, how rigorous you want to be in terms of doing your evaluation. But one metric that sort of stays, okay, is actually the cosine similarity with ground truth answer. So if you are somebody who is sort of looking into, you want to sort of stick with just one metric, okay, rather than look at all these dozens of metrics and still be confident that you are covered in terms of all the metrics. Look at this article. Okay, so here what we sort of demonstrated is that you may have lots of these metrics. Okay, like these are some of these metrics. Okay, they are coming from the Ragas framework. You have all these metrics. Okay, unigram precision, contextual recall, contextual relevancy, everything. And then you have this matrix, okay, metric which is cosine similarity with ground truth answer. If you optimize for all these, or if you just optimize for this, it okay, it doesn't make a difference. So that's what we were able to prove by doing benchmarking for different models, okay, across different type of data sets. So there are data sets which were having dense information, and the questions were related to reasoning. Then there were data sets which were sparse in information, and then the question was related to factual info. So we did that benchmarking, and what we found is that, like, if you just optimize for this one metric, you are safe. You don't have to worry about all the other metrics. Okay. So take a look. Okay, like that's what we concluded with, that instead of having so many metrics and evaluation, just calculate one metric and you will be safe. Okay. So with this, I would like to wrap. Okay, like the RAG fundamentals. Okay, we started from language models. We went into next token prediction. Then we looked at vector database. Okay, what is a vector? And then we looked at the overall RAG pipeline. Then we looked at some of the hyperparameters, the prompt that goes into it. Okay, along with the context, and then we are concluding with the evaluation metrics. Okay, so I think this gives you like a 1,000-foot view of how, what is the RAG pipeline, okay, what are the important components, and what are some of the hyperparameters and evaluation things that you need to keep in mind. Now we'll go into the depth part of it, okay, where I am going to not talk more about the information retrieval, because your RAG will be only as good as how good is your retrieval. Okay, because language model you can't change. You can't build the language model. So what you can really sort of optimize for is your retrieval part. And for good retrieval, you need to store it also well. How do you store it and how do you retrieve it can give you like a lot of sort of bang, okay, on your investments. Okay, so so do we need to take a break now? Okay, we take a break now, and then we start the information. Okay, so time, okay, what is the time? Okay, so it should be 12 now, right? So मतलब अभी ये 12:30 तक रखना था ये, तो फिर then we'll continue. Okay. हाँ 12:30 ब्रेक. हाँ ठीक है ठीक. Okay. ठीक है. Okay. So I think we have another 30 minutes. Okay. Just a minute. So we have another 30 minutes. We'll start with information retrieval. I'll go into some of the algorithms related to vector database now. Okay, and then we'll go for a break. Okay. So people who have questions related to vector database, retrieval, storage, park your questions. If there are any other questions related to things that we covered, we can. So first we'll go with offline part people, then online participants. Yeah, go ahead. आगे आ जाओ ना. See, that is the problem. You will end up with any other metric also. If you see, like if your context itself is evolving, then you'll have to continuously evaluate it. There is no other shortcut. How will you do that? Means think of it like, मतलब, as simple as this, के the reality itself changed altogether. Then you'll have to compare with that new reality, right? पिछली reality का कोई meaning नहीं है. See, it will become, I will say, so pay attention to this. So his question is, what if the context itself is changing? Suppose in a particular domain, okay, say related to, say verifiable AI, new research papers come into the picture, and then those new papers are proposing some new approaches, okay, new benchmarks. Then of course you'll have to compare with that new evolved context, okay, and this rather becomes an engineering problem than engineering design problem than a science problem, because you need to find a way, you need to engineer a way so that you can keep consuming that ever evolving context. Okay, so it becomes like a storage problem. How do you continuously update your vector database and stay it grounded with the latest information? Okay, so probably what you'll have to do is dump some of the old information. That okay, like now it is old. Okay, you put a threshold like anything which is more than 3 years old, I will sort of delete that. Right, and anything that is new, you are going to bring it into the picture. And other way of doing that is you can put weightages, okay, to the information. Okay, so in terms of weightage, you will give more weightage to the information which is more latest. Okay, so in the prompt itself, you will specify that, see, I am also providing some meta information, which is about when was this doc information created. Okay, and you will say, okay, pay attention more to the information which is more recent. Okay, so in that way, suppose you are retrieving your vector database on retrieval, it gives you say 10 chunks, and you have the timestamp information also, right? What you can do is to make the language model sort of pay attention to the timestamp, you can say also look at the timestamp. Okay, and based on that can sort of prioritize the latest information more than the old information. So in that way, you may not have to delete, but you can have your prompt take care of it. Okay, so let's move to the information retrieval part now. Any online questions?
Yes, one question.
Yeah, go ahead.
So let's say our chunk size is 512 bytes or 1024 bytes. So in case of search, the the size will be similar in search, or it can be different.
I didn't get your question. What do you mean by search?
So let's say we have chunk size of 1024 bytes, okay, and then we are searching some queries. So that particular query, search query will have similar size of chunk, or like how it will be identical in terms of searching that particular chunk.
Okay, so your question is like the chunk size of the query and chunk size of your vector database, should there be some overlap?
Correct.
Or they should look similar? No, 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 there's nothing like that. Your query can be anything, right? And that is something you can't control, right? Uska chunk size you cannot control. And different people will ask like questions in different lengths. So you can't really use that as a metric to determine your chunk size. Because chunk size is more like of a storage thing, right? Storage and retrieval thing.
Okay.
So, sir, prompting doesn't change anything, you mean to say. So, if we prompt better, we are supposed to get better responses, correct?
Yeah, of course. Yeah, means if your prompt is better, then you will get better responses.
Sir, audible?
Yeah. So see,
Yeah.
that is true with language models. Any language model, if your prompt is better, more specific, then yeah, of course you'll get better response.
Yeah, sir, was audible, sir?
Yeah, you are audible.
Yeah, sir. Thanks for your referring many of papers for us now. I'm able to see, but only problem we are not to note down. So, are we getting the slides and references, sir?
Okay, you want the links to the paper. So see, all the papers that, yeah, so you can just go to this link. All the papers are here. You can just download their PDF.
Yeah.
This link. Let me put it in the chat.
Yes, sir. Yeah, it will be great, sir. Thank you. And one more question, sir. Okay, it is on case problem. Shall I ask question this last, or I can ask now? One particular case of our requirement.
Case problem we'll discuss at the last. Okay.
Oh,
right now
okay,
let's
sir. Thank you.
go with the flow.
Yeah, thank you. Thank you.
Sir, I have a question about top K number. So, is there any optimal number as you suggested? Now the chunk size is it is like
See, again,
800
that is
to
also
1000.
dictated. Yeah, that is also dictated by what is the context window of your language model, right? And another thing is something called as context route. So one is context window limit, and another is like the concept that we are going to cover now. Even though you have more context window, it does not mean you should stuff everything. Okay, and why you should not stop, we are going to look now. Okay. Okay, so any more online questions, or otherwise we can go into the details of this topic. Okay, so yeah, so this was actually a tutorial at ICML, okay, and then it became like a lecture for then on that lines I created a lecture also for this session. Okay, so I think by now I think this is clear, right? That information retrieval is actually very, very important aspect of RAG. But how do we retrieve the information in a way that is always optimal? Okay, so that is where this concept of adaptive information retrieval comes into the picture. And I think somebody asked, right? Like there is dynamic, the context may be dynamic. Okay, so then how do you adapt to that context and retrieve the information? So we are going to look at those things, and I'm going to give you a flavor of like now with like the capability of that we get from the AI agents. How can we embed their capabilities uh, for better information retrieval? Okay. So again, for this also, I will start with a simple case study, which is from one of my previous paper. So let's look at the paper. Yeah. So this paper is also available online. So I'll just open that. Yeah, keyword augmented retrieval. Okay. So this gives you like a very good view of RAG also, retrieval, and then the approach that we highlighted in this paper. So if you look at your input document, what you do first, you clean it, okay, remove some of the new lines and spaces, okay, then you break it into smaller chunks. Okay, and one way is you convert them into vectors and store them into vector database. So like that is your regular approach, okay, when we talk about RAG. Another way would be, what if we don't really convert them into embeddings or vectors, but we identify keywords from each chunk. Okay, you can say lexical, sorry. We find out the keywords, okay, and we are using another small language model, keybert, okay, to identify those keywords. So now against each chunk I have keywords, and to find out these keywords I used another small language model. Okay, so we are not going the embedding or the vector embedding approach. We are not even using vector database here. Against each chunk you can create like a hash table. Against this chunk I have these keywords, right? So hash table you all would understand, right? So key value pairs, okay, another way of saying that. So now you have these keywords and you have these chunks. Now how do you use that? Okay, you store that, but now how do you use that, okay, when it comes to retrieval? So for the query also, you again from the query you find out keywords, okay, again using the keyword, which is a small language model, and then you compare the overlap of keywords, and you can put a threshold there that okay, 2 keywords match, 3 keywords match, okay. Based on that you identify what is the context, okay, then you put the prompt, have all these hyperparameters, and then give it to the model to respond. Okay, now with this very simple case study, what we found is we ran it over some of the real life documents, okay, and this table is sort of very, it's like a representation table, it is not very comprehensive in nature. What we found is when we were asking these questions and the information was stored in a vector database, So for all these first three questions, we were able to get a response even using the vector embeddings approach. But for the remaining three questions that I have lifted here, no retrieval was working. And the reason is probably the way we wrote page rank is actually different in each of these. Here it is together, here it is different, okay. There is a space between the two. And this information related to page rank was contained in the document. But still vector embeddings based approach similarity say we were not getting, it was not meeting the threshold and the criteria, and retrieval was not happening. If the retrieval was not happening, the response was also not getting generated. So that's why I'm saying accuracy is 0. But when we use keyword augmented retrieval, we were able to do some matching and we got the relevant context and the information came out. Another thing that you look at is in terms of the response time also. Keyword augmented or retrieval reduces the response time as well. Okay, so response times are also mentioned here. Okay, in the order of seconds. Well, this was done in 2022 with language models which were state of art at that time. Okay, GPT was not used; some other language models were used. So yeah, response times were quite high. Okay, inclusive of the retrieval and then response generation, they were very high. But when we response time are in some seconds here. Okay, now you will see that with the new age of language model, it will be in few milliseconds. So when we applied keyword augmented retrieval, we saw these time savings. Okay, and the response accuracy also went up, as you can see by these numbers. Sorry, what is? So keyword augmented retrieval. Okay, so again pay attention to this diagram. Okay, what we are doing is we are finding out keywords from the document rather than converting the chunk into a vector. From each chunk, I'm finding out keywords. Okay, so let me let me draw something. I said keyword. I'm using a keyword small language model to identify the keywords. No, we are not using regex. So suppose this is your chunk 1. Okay, it has 1024 tokens. Okay, against this, what we will do, we will identify few keywords. Okay, so suppose I got 5 keywords. K1 to K5 I got. Okay. Similarly for C2, I will again find some keywords. So in this way, I will get a table like this. Okay, for all my chunks, I know my keywords. And for your query also, I know my keywords. Okay, suppose there are only 2 keywords in the query. Then I am comparing whether these match with the keywords which are here. It's a very simple way, right? Like you can just do a check. Like you can just apply whether Q lies in K1, K2 up to K5. So it in terms of time also it takes very little time to make a comparison and retrieve. So that's why the time also goes down and the search accuracy also goes up. Now, would this always work or would this approach be always required? Now, when you have information which has got lot of specific terminologies, okay, or specific names. For example, well, Sachin Tendulkar as a name would be known to a lot of language models. Same would be for Narendra Modi. But there may be some other leaders also, politicians or scientists for whom the name is not very common or popular. Right? And suppose you are referencing them in your vector database, you have some information against them also stored. Now, what would happen because the language model can't really make sense of that name of the person. Okay? So it can't really create a proper embedding out of it. And when you try to compare your query vector and the chunk vector, there will not be a proper match and you will not retrieve the relevant chunks. But if you would have gone by the keyword approach, what would have happened? The name of the person would have become a keyword, right? Because any names or nouns end up becoming keywords. So here what you will have an advantage is, so this is just an example where I am saying the name of the people can become keyword, but there are other terminologies also. For example, if you go to say medical domain, like they have very specific name of disease, okay, very long, okay, say hypochondria, okay. So similarly like botany, zoology, like they would have very specific terminologies on which language models may not be trained. And when you expose these language models to those type of terminologies, the embeddings or vectors that you get won't really have a lot of semblance with the query. Okay, so query and chunk similarity will be low and retrieval will not happen. So the response will also not get generated. Okay, so that's where approaches like these do very well. Okay, where where you use keywords. Okay, rather than use embeddings or vectors. Okay, so and like the benefit of this is you save both time as well as improve the accuracy. Okay, you are able to cut down on the time also, response time also, and the accuracy also goes up. Okay, but at the core, what are we using here? What is the component? We're using another small language model to identify these keywords, right? So this is only possible when you have language models. But now we are living in the time where we have agents, okay, which are powered by language models, and they can do a lot of things. They can do a lot of thinking and reasoning. So why not use these agents to help us with the retrieval? Okay, so that is what we are going to look in this particular topic. Okay, of adaptive information retrieval. Okay, so we'll skip some of these things. Okay, so as I was saying that one way is like the traditional way of approaching information retrieval. You have like semantic similarity scores or cosine similarity. Okay, some distance based metrics, some lexical approaches like BM25 between the query and the retrieved text, and then based on that you will identify the relevant information. Okay, uh, but that will give you responses which may be factually correct. But how about really solving problems where you just don't need facts, but you need a lot of context? So think of a case, okay, where you are interacting with a customer support agent. All of us would have used them at some point of time, right? Some e-commerce website, you are talking with the agent. Now, earlier they used to have people who will respond to it, but nowadays it has become very sort of I would say robotic in the sense that they will have like some questions, okay, and you can only select those questions, and based on that some response will come. Right? They don't let you type the response. And why are they doing it? Because they don't want to put humans behind that. And what happens is, suppose uh, you are trying to make it understand some of the previous context. Okay, that chatbot will not get it, okay, because it can't really look at say messages beyond 5 or last 10 messages. It can't go and look at that. But think of the time, okay, when you had like humans who were supporting these customers support agents or bots. There the person can scroll and look up and down and see what all conversation happened, right? Even I think now also some of the e-commerce portals have humans. Uh, so you will say, okay, why don't you say they shift the support from one agent to another agent? You will say that just go look at the previous chat. You would not like to talk again, right? So that is where context engineering becomes important. That you would not like to repeat things which you already said. So again, like how do you leverage the previous or prior context information which is there to sort of give experiences which are sort of more aligned to what humans need? So that is where context engineering as a field becomes important. Okay. So now this is real-time context that is coming. This is not something that there is a document, okay, and you chunk that document, store it in a vector database, right? So and in fact, this information can change over a period of time, right? Probably on first week of say May, you are asking about canceling some particular order, and towards the end of the May, you're like, I want to know where my shipment is. So the conversations that are happening have completely changed. The context has changed, right? So so you can't really go and store all the information in a vector database and assume that you will be able to do a retrieval and then get good quality responses. Because there is some context which is relevant and there is some context which is not relevant. So the way to really handle that is where the field of context engineering comes into the picture. That you can't store everything in a vector database and get good quality tailored experiences. Okay, and in fact, context engineering as a terminology was invented only last year by Andrej Karpathy. Okay. Then there is another thing where whatever context that you have, now you can't really go and store all the context. So what you'll have to do is you'll have to rank the context. So how do you rank that context so that it remains relevant to the user is something is catered by this ranking of the context. Okay, and to rank this context and to understand what context is relevant or not, that is where you start using AI agents. Okay, so your information retrieval itself now has become can be supported by an AI agent. Okay, so the AI agent will do ranking of the buffer context. Okay, it will look at the user query, it will look at the data corpus and identify what is it that it should really store in the buffer and in which order it should store. So rather than converting a chunk and then storing every chunk into a vector database, now you have some intelligence here, where your AI agent is sort of looking at the conversation that is going on between the user and say some data corpus which is there, say profile of the customer. Okay, that is coming from a database, and it is not deciding and reasoning what to really store and in which order. Okay, and basis that the information gets surfaced, okay, while the interaction between the agent and the user is going on. Okay, so I've given you the motivation of the topic. Okay, we are going to look at real-time context. We are going to look at internal memory. Okay, and of course some case studies also. Okay, so RAG became very popular. Okay, 2021 onwards. Okay, but now with so much information really available and not every piece of information can be stored in a vector database. So a new field of context engineering has come into the picture. And another reason why this field of context engineering is coming up is again because uh, the context window of the language models have really increased. But if you throw a lot of information at it, then it tends to get confused. Okay, and it will not be able to generate a good quality response. Okay, and that is actually that thing is actually known as context rot. Okay, so context window has increased. Okay, so you can feed more information, but if you feed more information, then it becomes a problem of signal to noise ratio. How much information is really good quality with low noise, and how much should be filtered out. Okay, uh, so to address that, people do something known as adaptive curation. Okay, so in real time we are filtering the context. This is a layer over the vector database. Okay, that uh, the conversation between the user and agent is going on. Some information is there in vector database, some is not. Okay, so you keep on curating what information to consume from that ongoing conversation and what to really ignore. So um, it comes in these 5 stages. So First, you try to analyze what is the current state, what is the user really discussing. Okay. Then you try to identify that what is the missing knowledge. But probably I don't have this information coming from the vector database. So because this information is not coming from the vector database, so probably I need to look at the information which is contained in the ongoing conversation. So I'm calling that external index because this is external to the vector database. Okay, and then you like, okay, I found that okay, there are some pieces of conversations, some user messages which contain that information. Okay, for example, user may be asking about okay, where is this order and giving the order ID. Now that information may not be there in the vector database. Okay, so it identified, the agent identified that this is a missing knowledge. So from that conversation, it identified and now it is storing that in the context. Okay, so it got stored, and now when it has the information that okay, the user is talking about this order ID, then what it will do, now it is going to call probably an API with that order ID and try to fetch information from a database. So that is like executing the task. Okay, so here what we did is we could not find some information in the vector database, so we identified that this information is missing. Then we tried to identify and integrate that information from the ongoing conversations. Once we identified that, we used that to make an API call and do the task. Okay, so for 4, okay, but 2 and 4 you will require some intelligence. And who will provide that intelligence? The AI agent itself will provide you that intelligence to do the 2 and 4. Okay, and once it has got the information and it has found that this is relevant, after self reflection, now it is able to act on it. Okay, so from time where we were only looking at feeding factual information to the language models, when we really talk about the real world use cases, okay, where a lot of information may not be there, okay, it is information which is sort of dynamic, which is evolving, okay, as you are interacting with the agent. The way to approach is have these type of agentic retrieval loops in place. Okay, so I think we are right on time. Okay, it's I think 12:30. So we can take few questions. Okay, and then we can wrap up this part of the session. Yeah. Can you? Okay, so by external index, I meant like information which is content in the ongoing conversation. Okay, which is not really stored or indexed in your vector database. Okay. You can call it, yeah, you can store it in say something like Redis or cache, Redis cache, okay, which is external to the vector database. So I think, yeah, that is where you have to like stage 2, where you have to identify what is the missing knowledge. If say that missing knowledge is not really coming from the vector database, then it will have to go and scrape from internet. Exactly. Well, so for that you will have to write some logic, right? That if this is the query, so this is as simple as doing a Google search, right? So you would have something in mind, okay, when you do the Google search. So similar logic you'll have to feed into that agent as well, which is going to do the agentic retrieval. Okay, any online questions? Online participants, do you have any questions?
So we will continue this part because it.
Yeah, we'll continue this part. Okay, after the lunch. Yeah, 2:30. We'll meet again at 2:30 now.
Okay, and we'll have questions at that point of time.
It will be the same meeting link, right? After 2:30 also. Okay. Fine. We'll continue on the same meeting link after 2:30. Okay, 2:30. So we'll meet again at 2:30 in the same room. Okay. Yeah. So for the participant, lunch is arranged outside.
चाहे वो स्नैक्स थोड़ा सा कर याद ही लग रही है पढ़ाते पढ़ाते पानी पानी पी ले ली थी मेरे बोतल
Hello everyone. So lunch will be arranged I think at 1 PM outside. तो अभी आपके पास टाइम है, आपस में नेटवर्किंग कर लीजिए. You do the networking means you can talk with each other.